Be giving a talk today called Angular Best Practices. This is a talk that was originally given by Misko at the Mountain View Meetup, I think about a month or so ago, and that video is online if you ever want to compare this talk to that one and see how much better Misko does. I am going to open tonight with a joke because I love doing that, and you're a captive audience. So, 8 Bytes walk into a bar. They go up to the bartender and say, "Make us a double." Silence. Okay. So, Angular best practices. So, what do I mean by best practices? These are generally things that engineers, developers have figured out over time, things that make a project easier to maintain, make it easier for new people to come on board and immediately see what's going on. The term's pretty standard in the software industry, so I won't spend a lot of time on that. Today we're going to be talking about best practices as they are specific to Angular, and a little bit of best practices just for general web development sprinkled in. For some of the things I'm going to be talking about, we're not really going to be saying that there are good ways of doing things versus bad ways of doing things. It's more about presenting the different options that are available and talking about the trade-offs to those options. And most importantly, figuring out what's right for you with your application and your users. So, getting started, the first thing that we're going to be talking about is directory structure. This is first because it's usually the first thing people see visually when they start to build an Angular application. And when you go to build your Angular application, people say, well, what kind of folders should I have in my project? Where should I put my files? And to a certain extent, it's not super important how you organize your project, because you can use your IDE to quickly jump to any file. You can configure your build process to pull from any directories. You can have complete success if you put all of your JavaScript and CSS files and HTML files all in one monolithic folder. Obviously, you're not going to do that, but you could still do it if you wanted to. On the Angular GitHub, there's a project called Angular Seed. And this is kind of a basic Hello World project that the Angular team has put together to help you have a seed to get started with developing with Angular. And so we'll take a quick look at this and show just the example that they have for structuring your application. And you see in the root, this contains everything that your project needs for your development environment. And the very first folder here is called app. And the way this is set up is that everything in your project that gets deployed to production is inside of this app folder. So all of your controllers, your views, your whatnot are inside of that app folder. And everything that doesn't get deployed, such as your tests or your logs, those are outside of the app folder. Inside of the app folder, there's further structure for your JavaScript, images, CSS, and so on. It's pretty typical for projects to be organized with a folder for controllers, one for directives, one for views, but that is not strictly the only way to go. If you want to organize your project by feature as opposed to by type of component, that's perfectly okay. But the Angular seed is already here for you if you want to just grab it and get started. And another, how do I get back to my presentation? So another option that you have available to you is Human. This is kind of a tool set that is out there, open source project, that can help you, set up your project initially, set up your directory structure, but it also provides a whole slew of other tools, such as scaffolding commands, setting up your testing environment, running your test, managing your dependencies. And there's actually, I believe, a video available on the Angular YouTube channel that has a talk about using Angular in conjunction with Human to build and manage your projects. And if you are interested in that, you can get more information that way. Okay. So the Angular team, when they made this presentation, they inserted these moments of Zen into the presentation so that you can have a nice, peaceful Zen-like moment throughout the presentation. So this first slide is a moment of Zen for dependency injection. Dependency injection is a huge part of Angular. It lets you configure your application in different ways for different needs. Obviously, the best example of doing this is for testing. You can inject mocks or stubs into your code as opposed to the actual code that lets you test it in a more fine-grained manner. Also, if you have a service that you don't like that comes with Angular, you can write your own, such as a resources service or route parameter service. You could write your own and inject that instead of Angular's and use that instead. This gives you complete power over how your application is configured. And the most important thing about dependency injection is to just embrace it. Don't try to fight it or avoid using the injection. Angular is going to be much more powerful if you just stick with it. Okay. So moving on, script loading is a pretty important topic for performance reasons. You have a couple of choices when it comes to script loading. You can either go the synchronous route or the asynchronous route. Then there are advantages and disadvantages of each. So the traditional way we'll show by just going to our Angular seed app again. We'll see in our Angular seed that we have in our app 2 different index.htmls. Each of these demonstrates a different way of doing your script loading. So we'll look at the standard index.html first. And this is using the most basic common way of loading your JavaScript using script tags at the bottom of the page. As most of you probably know already, you put the script tags at the bottom of the page because script tags are blocking. It's synchronous loading. So if you were to put them at the top of your page, the user would see nothing while all of that JavaScript was fetched from the server and then parsed and executed. So we put them at the bottom of the page so the user can see all of your content. However, with Angular, there's a bit of a caveat here because for a lot of things, Angular is actually what's rendering your content. So it's possible that you have to have some bindings or some expressions that need to be evaluated before the user is actually going to be seeing what you want them to see. And so you have to be aware that that is not going to happen until your JavaScript is retrieved and executed. It's just something important to be aware of. When it comes to bootstrapping an Angular application using these script tags like this, you'll notice at the top of this page, they have an ng app directive on our HTML tag. And the Angular library is able to look for that ng app directive on the DOM ready event. And from that, it will bootstrap your entire application and do all of the compilation and whatnot that Angular needs to do in order to get started. So going back, the other way for doing this, for doing your script loading, is to do asynchronous loading. And you can do that with a lot of different libraries. The example that's used here is require.js because it's pretty popular. Require.js uses the AMD pattern, asynchronous module definitions. And it's important to note, just while we're on the subject, that the modules that are referred to by require.js, the asynchronous module definitions, are an entirely different thing than Angular modules. An Angular module is more about configuring the dependency injector, whereas require.js modules or AMD modules are more about defining the dependencies in your scripts and to say in what order and with what dependencies your scripts are going to be loading. And in this regard, the 2 types of modules are actually pretty complementary, and you can use them together without much fuss. Okay, so doing the asynchronous script loading, we'll look at the example that is on Angular seed, and that is in index async.html. And we go to the bottom here, and we see our script tags aren't here anymore. This is using an asynchronous way of loading all of these scripts. I'm not going to get into details of like whatever particular library is used to load the scripts asynchronously, but it's important to see this line right here. Because we are loading the scripts asynchronously, that we have no guarantee the order at which that loading will occur relative to the DOM ready event, so we can no longer rely on that in order to bootstrap the Angular application looking for an ng app directive. So there's no ng app directive here anymore, and instead we manually bootstrap the application once the scripts are loaded using this line here, angular.bootstrap. You give it your document and the name of your app. Both of these are options, and the route that you take in terms of script loading depends completely on your use case. It's very important to try out both ways yourself, do performance tests, and see what works the best for you. Okay. Okay, here's another moment of Zen. This is talking about wrapping callbacks for third-party APIs in $apply. So how many of you have ever done something in your application that updated your model and then your view didn't change? Some people raise their hands. So this is happening most of the time because you've changed your model in a place that Angular doesn't know about. So if you're using some third-party library that you give it an asynchronous callback that updates your model, Angular doesn't know that something has occurred which can cause the model to change. And Angular needs to be able to run a digest cycle, to run its dirty checking in order to see that the model has changed. And by calling $apply, you are going to force Angular to run through the dirty checking process to see if any of the model has changed and determine whether or not the view needs to be updated. Next thing to talk about, a lot of you may have seen this when you first started out, flash of unstyled content when your page is first loading, your index.html is first loading. And users will see on the page the double curly brace expressions as the page is loading. Obviously, this is really undesirable. This is being caused by the fact that HTML content is delivered to the client browser and shown before the Angular script has finished loading and executing in order to compile the HTML and turn the expressions into your actual content. And there are two solutions you can use to get around this problem. The first is to use the ng cloak directive. So going back to our Angular seed as an example, we'll see we have a style here set up for ng cloak that has a display none. And then this directive, ng cloak, is applied to the body of our document right here. And what this will do is hide your body until your HTML document has been compiled and is in a state that's ready to be presented to the users. So that will get rid of the problem of the user seeing your double curly brace expressions, but then you have a new problem, which is the users are seeing nothing on the page until Angular is finished loading and executing. And this is pretty undesirable because you're defeating the whole purpose of putting your script tags at the bottom if you're doing so. And it's not great user experience. So a better solution to solving this problem is to use the ng bind directives. And to show an example of this, we're going to look at the built with AngularJS site, which uses this. So here's the built with AngularJS. Now if I refresh the page, you'll see that right here, this count of projects, when the page is first loading, is a question mark before it resolves to a number. So we'll look at the source of that. And we'll see that this is actually not a double curly brace expression, but instead is a span that is using an ng bind to this expression. And by doing that, when the page is first loading, instead of seeing those curly braces, you're just seeing an empty span. And that is much more desirable, much more user-friendly. And by doing this, only on your index.html, the view that's going to be very first loaded when your application first starts, you can avoid this problem. So, and typically your index.html is just going to contain your application Chrome, your navigation, and your container for your views that the user will see as they navigate throughout the application. So it's generally pretty minor to do this. Next thing to talk about is something that's very important in JavaScript applications, which is minification and compilation of your JavaScript code. And the first question to ask yourself is whether or not you really need it at all. If you're working on a small toy project or just something to play around with Angular, then minification is probably not going to be a big deal to you. In general, according to the Angular team, Angular applications generally have much less JavaScript code than equivalent applications that are written using raw DOM manipulation with something like jQuery by itself. And because of that, the need to use minification and whatnot is somewhat diminished. However, if you're writing a moderately sized or large application, minification is still definitely the route to go. But if you're going to be doing it, there are a few caveats that are specific to Angular that is very important to be aware of. The first is that views use reflection in order to access the model. So when you reference a property inside of your view, such as having a double curly brace expression and doing something in there like item.name, it is very important that those properties exist exactly as they are written in the view in your model. If you're running a minifier at the full minification settings, one of the things that will be turned on is property renaming, which will compress all of the JavaScript property names down to single letter variables or really short variables names that will take less time to transmit across a network, but will totally break your Angular views. And it depends on your minifier how you to get around this. You could just maybe turn off property renaming, or maybe your minifier has settings to specifically state which properties do not get renamed, and you can annotate those in some way or configure it. But the important thing is that you do configure it not to minify those property names. The second thing to mention about Angular minification is the dependency injection. So Angular, by default, will use dependency injection based on the names of arguments into a function. So as an example, we typically have dependency injection that looks like this. You have some controller, and this is injecting the scope and is also injecting some service called greeter that is provided by the provide service. And if you do not configure your minification the correct way, these properties, these function arguments are going to get renamed to something shorter, and your injection is no longer going to work. So a way to get around this is Angular is aware of a property that you can add to functions called $inject. And you can set this property on a function, $inject, to an array of strings, where the strings are the names of the services or whatever you're going to be injecting into that function. And by doing this, it completely avoids the issue of renaming the function arguments in the minifier, because you're explicitly stating which and in what order things are going to be injected. Now, this syntax works really well for things like controllers that you're going to be instantiating anything that you're going to be making with a constructor. Sometimes, though, the syntax is kind of clunky if you are going to be inlining a function. For example, if you are creating a service that you need to inject some things into, you don't want to break this function out into another variable so you can set the $inject property on it. So there's an alternate syntax available where instead of providing the function, you can give an array in place of that function, where the array contains all of the injectables named as strings in order, and the last element of the array is the function itself that is going to be taking in the parameters that are the injected services and whatnot. And this allows you to inline your explicit declaration of dependencies in a much syntax-friendlier way than being able to have to set this $inject property. Okay. And the last thing that is mentioned about minification is to never compile or minify angular.min.js because it's already minified and compiled. And the Angular team has probably done a better job than anyone else would do. And really this goes for any third-party library you're going to be using in your application, whether it be jQuery or underscore or anything else. All of these libraries have a minified version that they've already figured out as being the best way for them for their project. And so you definitely just want to use what is provided for you, and if you need to, concatenate it onto or before your JavaScript. Okay. Here's another moment of Zen. Take a deep breath. So don't fight HTML. Extend it. So I believe the motto for Angular is HTML enhanced or something like that. And Angular, it really wants you to embrace the HTML and not abstract it away behind other layers or other type of view engines, and just go ahead and use the HTML and extend it with Angular using directives. So there are, when it comes to directives and putting them into your templates, there are a lot of different syntax options available to you. So for using a directive, there are 4 different syntax options. The first is the element name or the tag name syntax, where you create a tag yourself that is the name of your directive. So this allows you to do things like create a tab element or a slider element when no such thing really exists in HTML, and it's really clean. However, there's some compatibility problems that I'll talk about in a minute. Another thing is you can use the attribute annotation by just taking a div or any other element and applying onto it an attribute that has the name of your directive, and Angular knows how to compile that. The next is by setting a class name with the name of your directive, and the last is by using a comment in this syntax that you see here. And these last two, they can be kind of odd at times because it may not be what you're expecting. It can be somewhat surprising to find that setting a class or adding a comment to your page can actually change the behavior in some way. But it is useful at times. For example, the comment syntax is very useful in times when you need to add a directive into a place where something else would not be valid markup. For example, if you needed to wrap the inside of a T-body in some way in a directive. Normally, the only thing allowed inside of a T-body is a TR, but you may want to wrap something else around that TR to perform some pre-processing or some extra work in some way. And using the comment that will actually give you HTML that is still valid. And another important thing to talk about when naming directives is it's important to give your directives a namespace. So the Angular directives that are provided in Angular by themselves use the prefix ng. And when you make your own your own directives, it's very important you come up with your own namespace to avoid conflicts. Definitely don't use ng. That's reserved for the Angular team. Only they get to make directives. And even though people have done it in the past, it's not really a good thing to do because you'll run into conflicts if they ever introduce new directives in the future. And also for third-party Angular libraries that you're going to be using, you might run into more conflicts. So definitely based on whatever the name of your project is, come up with a prefix. And for applying those prefix, there are two different syntaxes you can go with. The first is to use your prefix dash. The second is to use the colon with the XML namespace notation. And that brings me to the issue I mentioned earlier about compatibility. Internet Explorer has some problems with both the colon XML namespace notation and the tag name notation for directives. Both of these issues have workarounds that you can read about on the Angular documentation. There's a whole page here about Internet Explorer compatibility. It's long, it has lots of technical details, and I'm not going to go into right now how to implement those workarounds for IE, but they're there if you really like the syntax. Optionally, on one last note, it's possible to make your HTML standards compliant and valid by adding prefixes to your attributes when you're adding directives if you're using the attribute syntax. So by itself, the my-component syntax as an attribute is not valid HTML because my component is not part of the standards for the specification. So you can optionally append or prepend an X or a data dash to your directive names in order to make them standards compliant. Either of these are allowed via the specification. For like data, for example, is for just storing whatever arbitrary data in attributes. And Angular will automatically know how to look for these, and you can do this and still pass validators. Okay. Another moment of Zen here. Separate presentation and business logic. This isn't really so much Angular specific as it is for all of software everywhere. So getting into like how you should structure your business logic is that the most important thing is that controllers should not ever reference the DOM. Controllers should be designed to act as a glue between your view and your services, and the controllers model the view behavior, but any actual DOM manipulation itself belongs in directives. And services are also something that should not really reference the DOM. However, there is a bit of an exception. The exception is when you need to perform some very small amount of DOM manipulation. It doesn't really make sense as a directive. A good example of this is having a dialog service. So it doesn't really make a lot of sense to have a dialog directive that you're going to put on your page and hide or show based on some model value. It does make a lot of sense to have a dialog service that you can invoke and say, open up a dialog. And this dialog service will be performing some very minimal amount of DOM manipulation by loading a view and attaching that to one place in your DOM tree. And this minimal amount is okay, but it's very important to try to keep it as small as possible, because if you start doing more, it's going to make your testing story a bit more difficult, and that's really undesirable. Another thing to mention about services is that they are singletons, and they have a lifespan of the entire application's lifespan. So any logic or anything you need to do that has a state that is persisted as the user navigates around the application belongs in a service, because as opposed to controllers, which are instantiated and destroyed every time a user changes their route or moves between views. Then treat scope as read-only in templates and treat scope as write-only in controllers. So read-only in templates, I feel intuitively makes a lot of sense when you are writing your templates either for just regular pages or for directives. It makes it very difficult to test if you are changing values of your model inside of your markup. It's much simpler if you perform all mutations on your model inside of your scope through the code inside of your controller. As for write-only in controllers, to be perfectly honest, I don't really get what that's all about. I tried to ask Misko about it a little, and it was his response was that you should really be not reading from the scope directly inside of your controller, but instead you have some local variable inside of your controller that you are reading from and performing writes to your scope. So talking about the scope, this is kind of echoes what I was just saying. One common misconception that people have is thinking of the scope as being your model, but a better representation to have in your head is that your scope is a container for your model, or for several different models, or view models, or whatever is appropriate in your case. This is something the Angular team has seen pop up a lot. They say they probably get at least one bug report a month about this issue. And this is when doing bidirectional binding with an ng model, make sure you don't bind directly to scope properties. This can cause unexpected behavior in child scopes. So this is an example bug that was reported by someone on my team, actually. That we're going to open up this fiddle. And what we have here is an ng switch directive. An ng switch creates its own child scope, and the bug is claiming that when you are in your parent, when you have an input that's bound to the same thing in both the parent and the child scope here, you can come in the parent and you can change this. Wrong one. These are not in the order expected. So you're in the parent, you can change this, and the child will reflect those changes as you would expect. But as soon as you come inside of the child scope and you change this, they're no longer in sync, even if you come back and edit this some more. And this is because of the prototypical inheritance nature of scopes. When the child scope is performing some binding to a property, in this case it's called the field. When your child scope is binding to the field, it's going to see if it has a property called that. If it does not, it's going to go up to its parent, see if the property exists there, and if it does not, it keeps going up until it finds somewhere in the prototype chain that does have this property, and then it will bind to that. As soon as you introduce that property in the child scope, which I do by changing this input in the child scope, I'm defining it on that child scope. So it will no longer go up the prototype chain in order to find that property. And when you change it on the parent, it's going to be an entirely different property than what's in the child. And this is intended behavior. And the way to get around it is by not directly accessing properties like this when you're doing this bidirectional binding, but instead to use a dot notation. So you would do something like store the model that you're binding to on your scope and reference it in your view with something like model.thefield, or perhaps item or user or whatever is relevant to your case. And this comes up very frequently, again, the Angular team, so don't report a bug if it happens to you. All right. Next moment of Zen. The watch getter function must always be fast and idempotent. So what idempotent means, if anybody doesn't know, is that you can keep applying it over and over again without actually changing anything. So watches are called very frequently by Angular, and because of this, they really need to be fast. If they're not fast, your application is going to start to hang as you have more and more watches. And secondly, there's no guarantee by the application as to how many times that watch function is going to be called. And because you have no guarantee how many times it's going to be called, it can't have any effects, any side effects that are going to be depending on it only being called once or no times or 7 times. It just needs to be able to be executed over and over again without affecting your application negatively in any way. Okay. So next thing to talk about is modules. So modules are somewhat used to manage dependencies in Angular. So if you're using a third-party library such as Angular UI, that third-party library would have its own Angular module, and you could depend on that module with your own modules in order to define that dependency and tell Angular about it. People tend to see this idea and kind of go overboard with it and make modules for everything. The example that the Angular team used was having a module for controllers and having a module for services and having a module for your filters. And this is generally undesirable because it prevents it. You don't really have dependencies that you can manage for different parts of your application in that way. It's generally more desirable to break up your application into modules based on features. So this allows you to maybe only spin up only part of your application if you're testing, instead of, because you're not going to have a controller or any controllers that don't depend on any services whatsoever. And if you break up your modules into all controllers and all services, then you're not going to be able to test any controllers without bringing in the dependencies for all of those services. This isn't the case right now, but one thing the team is looking into in the future is using the modules for incremental code loading, or lazy loading of your JavaScript code as you navigate throughout the application. And this would be done by grouping your application into modules per view. But this is still something that is really just an idea and not functioning right now. And so almost done. So next mode, then, develop with non-minified libraries. I think this slide is mainly in here because the Angular team is never happy when they get a bug report that contains a stack trace with angular.min.js because they have no idea what the stack trace is actually telling them. So when you're developing your code, be sure to develop with the full angular.js alongside of your full version of jQuery and underscore. Not only will it help you in debugging or submitting bug reports to these projects, but it also lets you, if you're having a problem or even a performance issue, jump into the library that you're using and see what's going on so you can be better informed. It's a bit more work to deal with like your build time, but it's definitely worth it. Okay. And the very last thing I'm going to talk about is deployment techniques. So things you should do when you deploy, minify and concatenate your JS. As far as concatenation, this may not be such a huge thing for much longer. Browsers are getting better and better at parallel loading of scripts. So it's really a up to you whether or not you go with concatenation, do your own tests, and figure out the performance benefits for your application. Next thing you want to do is, of course, gzip enable your server. This is going to save you a huge amount of data that's being transmitted across the network. Obviously, this isn't specific to Angular. This is just general web development. Make your index.html non-cacheable while making everything else cacheable. And what this will do is allow you to deploy new versions of your application without having any worries about the caching being, or having a user with invalid cache that's sticking around. By updating your index.html to a new version, you can change what JavaScript files or what images are listed inside of it, while those scripts, if they are unchanged, can remain cached on the user's browser. So that concludes everything that I had to talk about. Any questions?
In the bit where you talk about directives and what works, and the certain syntax for writing directives works across all browsers. Some only work some don't work in IE. My question is, does using the replace property on a custom directive preclude the need to use IE-friendly directive tags because you're replacing them before they're being rendered to the page?
No. So that tag, as far as I know, is still, Angular is not going to turn it into a div or something similar. It will leave it as the tag that it is. And by default, Internet Explorer, I forget which versions do this, but definitely 8, will render that tag in a completely unexpected way. It will be something like you have your start tag, and that's standalone, and then your content is another standalone tag, and then your end tag is another standalone tag. And the workaround is to do a document create element before your HTML is loaded. But to answer your question, I don't think that using replace will let you get around that.
Hi, can you speak to any risks that might be associated with using the class-based directive declaration, like conflicts possibly with existing CSS?
As long as you are not putting styles on those classes, I don't think it would really be an issue.
I mean, you might have a big team, and you might have one team responsible for doing the CSS and another for creating the directives. Yeah. So has anyone actually run into this issue? I
mean, I've never seen the class syntax used myself, and my advice would be, if you're worried about it being a problem, then don't use it.
I was a little. I was a little confused about the templates and scope. By definition, when you have an input statement and a scope variable in that input statement, wouldn't that be writing in the template? Or
are you talking about what I was talking about with the ng switch and the parent versus child scope?
No. Read-only templates and the scope?
So, as an example, it's possible to create a button and give that button an ng click that says item.name equals Larry. And that would not really be a great thing to do, because it would be really hard to test that button is working correctly. It would be much better to have the click for that button be like calling a function that's a set name, and have your controller deal with the writing of that value onto your scope model.
There's a Chrome extension built for Angular.
Battering?
There's a Chrome extension for Angular, and
yeah.
I was wondering, do you use that?
I don't use it myself. The last time that I tried it, it was, I believe, still in beta and had some issues, and I haven't gotten around to revisiting yet. That's really just me.
Okay.
Over here.
If you're gonna use the Angular with like Twitter Bootstrap, is there anything that you need to be careful?
What was this? Oh, with Twitter Bootstrap?
Yeah.
It depends on what you're doing with Twitter Bootstrap. If you're just using the CSS, then I'm not really sure you would run into any major problems. If you see, I'm only passingly familiar with Twitter Bootstrap. As far as I know, it provides CSS that you can use to do things like make buttons and menus. Does it also provide like, JavaScript?
Yep.
Okay. Yeah. So I don't think I'm actually very qualified to answer that, but if you are just using it with the CSS, I don't see a lot of issues. As far as the JavaScript goes, without more familiarity with the library, I don't know if I could really answer that.
You have any recommendations on structuring your server-side partials? Let's say your partials are not just HTML, but they are coming from either a Node, Jade, or something like that. It's like, how would have you seen this scenarios like that? Like, what would you recommend?
Well, I know it's possible. It really depends on your specific application and what you need the server-side rendering to do. I've seen pretty much exclusively in the past, in my experience, using just regular HTML files without really any server-side rendering for the most part. And I think that goes along with the best practice suggested by the Angular team to just embrace HTML and not try to abstract it away by using server-side rendering techniques. But it really does depend on your specific situation more than anything else.
Is there any best practices as far as watching a large number of fields that all ultimately do the same thing, such as storing a local service or something remote?
So just in general, like having a very large number of watches?
Yeah, so let's say you're trying to watch 10 or 15 different fields that all ultimately are on the same view model.
Mm-hmm.
Would you want to register 10 or 15 different watches, or would you try to want to get one watch and then combine all of those attributes into one watch statement?
I actually don't know off the top of my head which is better performance-wise. Definitely it would be more readable to have separate watches, but Carl, do you know?
So it's going to depend, it depends largely on the size of how much else is in that object, because if you were to just watch your model object, then Angular is going to keep a deep copy of that for comparison purposes, and it's going to do a deep comparison on each digest cycle. So if you're looking at 15 fields in an object with 18 fields, that's probably fine. If it's much huger than that, then you might want to watch them all individually. Key thing to be careful about is you'll probably want to rig your callback up so that it only calls when one of them changes, not when if 4 of them change at once, it probably only needs to call your callback once, not 4 times. So just make sure it's not doing that.
Thanks.
Okay, so question back there. I don't know how we're doing on time, so if we're
okay, I have a quick question. So in the synchronous pattern of Angular development, script loading is a blocking. We know that, given that fact. Is it ever possible to load JavaScript in a parallel fashion in a non-blocking way, like when using the async Angular.bootstrap?
Well, yeah, that's there are 2 options for loading scripts, are either synchronously using the script tags or asynchronously. How you're doing that asynchronous loading is up to you. There are a lot of different libraries out there. There's Require.js, there's YepNope, there's probably 40 different others. And if you are doing that it's up to you to like configure how you're doing managing the dependencies of that async script loading, triggering it. But the important thing to keep in mind with Angular is that once the Angular script is loaded, you do manually have to call angular.bootstrap in order to start your application.
Okay, so I think what I meant to say also was, is it possible to parallel load JavaScript? Is that ever possible when using the async?
I mean, sure, if you're using an asynchronous script loading library.
So two different JavaScript dependencies could be loaded at the same time?
As long as one doesn't depend on the other.
Okay. Cool.
I'll caveat that, like, it depends on your browser. Like, older browsers will load them strictly in order, and like, I don't know how good the new browsers are at like lexing them in parallel, and it obviously has to execute them in serial. So I'm not really sure how much you would get from that.
Time it takes to load individual files, and then but my question is about performance.
Yeah, I'm not sure that you would get better performance by doing that. I think the main performance you get from dynamic loading is just that you don't necessarily have to load everything right away. Maybe you can wait until the user navigates to some other part of your site to load the JavaScript for that part.
Any other questions? Great. Thank you.
Are you sliding?
We have one more talk, so stick around. And then lightning talk.
All right, so HTML5 video and directives, everybody's favorite topics, right? And if I get some love from the demo gods here. All right, there we go. Whoops. All right, well, anyways, so that's the nature of the talk. I'm going to show you how we built this video player. And if I had sound going through the computer, you could probably hear that a little bit better. But essentially what this is your standard HTML5 video player, but it's comprised from a series of Angular directives. And from the control bar to an abstraction layer that handles a third-party video library, to things like the volume slider and the progress slider here that you see. Each one of those in turn is an Angular directive. So let's dive in and take a look. What were the goals for this? Well, obviously we wanted a reusable component which could be interspersed throughout our app. We wanted a self-contained set of logic to control video playback. We could just configure each one of these instances and play the video. And thirdly, we didn't really want to be tied to a video library. I don't know how many of you have worked with HTML5 video libraries out there, Media Element, Video.js. None of them are 100% great right now. But so anyways, this allowed us to kind of not adhere to one and maybe swap it down the road. So what are the pieces? Well, it consists of, like I said, a series of directives, the main one being the video player itself. And when we look at that, that is a directive which encapsulates all of this, right? The second piece is the video library abstraction layer, which we'll get into shortly. The video library that I'm using here is Video.js. Thirdly, we have a directive for the controls themselves. And we have one for the progress bar and volume slider, which I spoke about. They live inside of this video controls directive. And then finally, we have one for the image that you see on the screen here. This is known as a poster image. So the HTML5 video tag has a poster attribute that can be problematic on certain browsers. We went ahead and kind of wrote our own that essentially mimics that same behavior. So stepping in, our first and parent directive is this video player. Let me know if the size here is readable. And like I said, that sits around everything. So this is what your directive syntax looks like. You see we're setting it up right here inside of Angular. This will be our tag name when we go to insert this into our markup. And we're configuring a number of options. The first one here is restrict, and we're setting this to E. That will restrict your directive to an element. You can change that to attributes, among other things. This replace here, when we set this to true, is going to replace the custom markup that we're creating with the template URL that you specified, that you see specified here, and that looks like this. So our custom markup would be literally an HTML a video player tag, and at compile time that would get translated into this, which is essentially just a div, and you'll see again the child directives nested inside of that. And I know there was a note on the different directive markup syntax, but it's a lot more gratifying to see your own custom HTML tags. So try that out before you switch over to class names or comments or something. The third thing that we're setting here is scope. And so what this does, this creates an isolated scope that is shared among all of these different directives. And you can see that I have a couple of properties here: video, heartbeat frequency, and classes. And what this equals syntax says is that when you're configuring our video player directive, you can pass in these three attributes, and they'll get appended to this scope that is then shared amongst all of our directives. And so on our parent directive here, we have an inline controller. And that, the reason behind that was so that, you could render one of these and not have a dependency on a controller that you may have somewhere else in your application. You can see here that we're just keeping track of state on a couple of these members here. And again, these are shared amongst all our directives, so they all have access to them. They all can read them. They all can write to them. We have some simple methods to just toggle the play state, full screen state, and so I could have written controllers here for some of the other directives that needed to broadcast, some events that were occurring, but chose to do it here inside of this parent controller. That we only had one controller for this series of directives. Okay, and so in this case, we don't have anything inside of our linking function, but what that is that's the glue between any sort of DOM manipulation that we have to do and our controllers. So, moving along to our next one, that is this video.js, the video abstraction layer. And what this is essentially a directive that allows us to interact with video.js in an encapsulated way, so that should we need to switch that out for a media element or something else down the road, we can do that. And you'll see, again, restricting it to an element, replacing the contents. In this case, the contents look just like this. They're just plain old HTML5 video tag. You can see in the previous directive that we had, the video player, we were passing in this video object. And all of these properties, ID, width, and height, from that video object are getting interpolated into this tag right here, this HTML5 video tag. So this one definitely does have a linking function. And you can see in this linking function, the first thing we have here is a call to video.js. And we're passing in the element that the linking function provides to us, which is essentially this video element right here. Right? So we're just initializing video.js in this bit right here. And then you'll see a bunch of callbacks defined, but let's go ahead and take a look all the way down here to our video.js ready method. And all this is video.js itself notifies us when it's ready to begin playback, when they've gone through and done all of their DOM manipulation. And that's a good point to note, because a third-party library might be doing things that are outside of your control or that you're unaware of. Having it inside of a directive keeps it safe within your application. So we're calling source and size, again, with properties from the video object that we passed in way back here on our parent video player. And then you can see all of these events and their callbacks. So let's take a look at some of those. Okay, so Lodestar is just a callback that gets called, but it gets called within the context of Video.js and not Angular. So, as you can see, that could potentially be problematic. The way that we can make Angular aware of any changes, in this case to state, is by using apply. And additionally, we're broadcasting that, and anybody that was looking to listen in can listen in. And so we'll go through this in a little more detail later, but that's essentially what all of these are. And then we have our video controls. So those essentially just serve, because I wanted these to share scope. Essentially what these are a template that gets loaded along. And you can see what those look like right here. And so here, obviously, is a non-standard HTML element. It's just another directive that we've created. You can see classes, an ng class being applied from attributes in our parent controller. So that's setting this to either true or false. Again, properties that are on our parent controller. You can see what this looks like by, these are being run through a filter, but essentially, as the video goes on and on, the current time and the total time get updated. All of that. And so finally, we have our volume, our custom volume directive. So those are the controls. We have progress bar. Looks like that, right? And so you can see in this particular directive, we're doing a fair bit of DOM manipulation, directly calling Angular Elements CSS method. And so this is clearly a safe place to do all that. Binding to the scrubber itself, so that, again, we have this notion of our parent directive that's kind of maintaining the scope, and we're modifying that on the change event here of this slider. You can see how the seek is being set and passed down to this directive here. We're watching that somewhere in here. Here we are, right? And then just calling in turn Video.js's current time method, which is going to update our video to a different point. So that's the overview. Those are all of the pieces that make up this set of directives. How do we configure it? So as I briefly mentioned,